So, so hi. Today the main topic is just kind of recap of or re-explanation of the scheduling. So the main topic is scheduler. So, what is scheduler and why do we have to know about this? When you're trying to use some computer, your Mac OS, Mac or whatever, or ThinkPad, you're basically using an operating system, the Windows operating system and the Mac OS operating system, Windows 6 operating system. The operating system is kind of what I believe is kind of obstruction of your computer architecture. In Mac OS they use ARM computer architecture, and in Linux they use x86 computer architecture. Based on this computer architecture, operating system do some kind of optimization. Example, the process or memory management, or yeah, it's just there are a lot of things, or virtual memory, those kind of things. So basically, what I believe is the operating system is just the obstructions that do everything for your computer architecture. But in so let me try to just give some kind of easy concept that what is the program. Program is actually it's just the bunch of instructions. A program it's just a bunch of instructions. So instructions means that you tell you tell your computer CPU do whatever stuff. So this is called the instructions. I think there's more great where was it? I think I'm looking for the lines of it. Yeah. So there's gonna be so let's say this paper is a bunch of instructions. So program is a bunch of instructions, and instruction is the thing, is the code that you do what to do with your computer. But when trying to click the program, example, your browser Chrome, if you're trying to click the Chrome, Google is gonna be the process of it. So process means that it is running instance of their program. So process means that running instance of your program. So program is kind of static. It's just a bunch of instruction, but when it's running, it's just the process. So the reason why it's saying the running instance of your program is it's not really kind of one of your program. The process doesn't represent the one process doesn't represent one program. The instance means that let's say you have some kind of car, and you generate some kind of instance or object that the extends of the car, which is Volvo car or Lamborghini, whatever. So those kind of thing is instance of the car. So process is gonna be like this, process 1. So this is program. So it's just the instance of your program. But so which also means that there could be multiple process in your program. Like browser, the Chrome is multi-process application. So there's a lot of process. Example, let's say let me try to find the Chrome of it. Yeah, let's just say this is the browser, and let's try to think. I don't know how to find the wait, let's just say look at this. So this is actually not load balancer. Yep, like this. So in your program, this is your browser. Browser is actually representation of the multi-process application. which means that there could be more process of it, a lot of process. But the question is, we know that computer only execute just one by one, because if without operating system, if you look at how does it work, the computer just read the instruction and execute by per instruction. There's no the concurrent instruction doing. It's just the line by line. But there's a lot of process. But how do we kind of handle those kind of thing? This actually, if you look at my video here, this is Obsidian. This is actually a process, and this so these are so the OBS Studio is its application, and there's process running. But when I'm trying to switch the screen, then it also indicates there's some kind of logic in there. But how do we really make it smoothly? I'm trying to use Obsidian right now, but just like 1 second ago, I just shared my screen of OBS Studio. So how does it really possible? It is because the scheduler, there are a lot of process, and the scheduler is handles the schedule of your process. What I mean is schedule the process. Like if I try to use some kind of feature in now Obsidian application, that means that I'm using some kind of process in Obsidian app. That means that the priority of this process is more advanced, or there's more priority than I open the Google or Chrome. So the scheduler is to think about those kind of way and make it as a possible, and like optimize as a possible for it. And the process is not really kind of like the magical thing. The process is actually the object. If you look at the code of here, like Linux, their code, the process is actually the object. There's a kind of code that operating system gives memory to the process, and process holds their own data structure, and also code the process control block PCB. PCB also stores the current state of the process and a lot of things. And the scheduler is the one who handles those kind of things. There's a lot of types of the scheduler, but let me just try to explain the 3 types of basic scheduler. One is FCFS, first come first serve, which means that, example, there's a queue of here, there's just a queue, and also let's say there's a process you have to handle. This your operating system has to handle, without thinking about like how many times it's gonna be cost or running this process. It's just executing when the first comes first serve. It just did using the basic data structure, which is queue, because queue also follow the structure, which is FIFO, first in first out. So this is, let's say this is the queue that we wanna execute. We don't think about how much is gonna be cost or not. We just execute this part. And next thing is process 2, and next thing is process 3. Do the same thing. So that's kind of basic of the for FCFS. And next thing is I forgot the word of the English. Next thing was I forgot the word of it. Hold on. FCFS scheduler. Yeah, I think it was FCFS, and what's the next scheduler? Basic scheduling algorithm. I forgot the word of the instead of FCFS. Oh yeah, sort this out for SJF. Oh, I'm stupid. So SJF is just basically things that, okay, so the problem of the FCFS is that even though it takes some kind of a lot of seconds, this process has to wait. So that's going to lead to starvation of it. But SJF It's basically things that shortest job first. Shortest job first means that shortest go first and the longest go last. But also there's also means that it's pretty fine, but it's kind of modern, and not modern, just the basic scheduler, shortest job first. And next is round robin. Round robin is basically, it's very simple. It's kind of, the keyword is kind of hard, but if you look at closely, it's kind of easy. Since round robin, the basic goal is there was a limitation of the scheduler, example FCFS, that could lead the process have the starvation problem, and round robin is basically split this kind of cost of the process and make sure that each process have same amount of execution. Not execution, it's just like allocating based on the time slicing. So before it was like this, but it just time sliced based on that. It seems so. If you look at kind of this way, it's gonna be more convenient to understand. There was some kind of king in the Bible. It was a Solomon. So there was a two mom that saying the baby is mine. The other mother also insists that this baby is mine. So what Solomon King does is, wow, well, just slice the baby into half. Well, he was just lying, but so those kind of thing is actually similar to round robin. It's just like time slicing base rather than think about the priority. So this is it. So today main topic was the basic scheduler. Why do we need scheduling and what's the background of it? So this is it. Have a nice day and see you next time. Bye bye.